Hi, welcome back to my channel. Today's video is talking a little bit about the limitations of LeetCode, or looking at how small problems really doesn't lead to how people do things in the context of the real world or in larger code bases. And what LeetCode is that there's a site, it's a large set of programming challenges. You can track your progress on there. There's all sorts of social and gaming finding features out there. It's become very popular. And that's also kind of a meme for certain types of coding problems because it does focus on a certain set of computing that's very specific. And what it is that it's really these small problems and how you could use certain data structures and algorithms to solve those problems. And of course, computational complexity is a big part of these programs, or if you're aware of computational complexity, it's what people call O notation, you know? So I was like, what's the O notation for this? Or, what's the complexity for this algorithm? This is a very useful set of concepts to understand. Don't get me wrong, but they're applied differently in larger contexts than they are in this very small. And not only that, but they're not the end all be all of computer science by a long stretch of the imagination. The other thing that comes up is a lot, you see a lot of these things in context with this whole coding school, get a tech job in X months type of things. There's lots of companies out there that are doing this in terms of online training. Some of them I really like overall, like Treehouse. They do some really good stuff around training. They kind of put they put themselves in this space. A lot of them are very good intentioned. Others maybe not so much for. They just kind of want to get your money and move off. The problem is that none of that is sustainable in the long term. You're not going to be able to get a tech job and sustain a career by just doing it in 12 months. You would already have to be just very, very naturally inclined to do that kind of work. And if you were, you would just basically have done all that teaching by yourself using free resources. You don't necessarily need to organize the coursework. You would have self-organized your study. And the amount of people that can do that is just vanishingly small. And so the vast majority of people, yes, the best way to get a tech job in programming is to do a 2-year or 4-year degree. And the reason is that those programs will focus more on fundamentals and what you need to know to further yourself in a career than these coding schools, which will basically take in a lot of assumptions. Not only that, but there is value in a 4-year degree or a 2-year degree in terms of general knowledge. And that really is important for getting jobs as well. It's not just being about a good coder. It never has been, never will be. Having a certain ability to be able to learn by yourself, to motivate yourself to do certain types of things, to have certain critical thinking skills. There are some things about a 2-year or 4-year degree that help show that to employers that it's hard to do without those types of things. And again, there's people out there that don't need the degrees that are very good at it. So these are the exceptions, but I think they really apply as exceptions that prove the rule that you're better off getting a 2-year, 4-year degree. Again, as an aside, are those degrees too expensive in general? Yes. Um, Education and higher education should be much more affordable in the United States. And so I won't argue with anybody there, nor will I argue with somebody that doesn't want to take in that amount of debt. But the thing about it is that a lot of these companies actually do quite charge a large amount of money for some of these programs, and you can actually get very little return in terms of the actual ability to get a job or keep it. And the reason it also comes up is that a lot of them, it's like, well, I'm going to teach you how to do these LeetCode things to crack the coding interview, as if the hardest part of getting a job was just getting through the interview. Certainly, it's a critical part of it, but it's not the only part. And it's not the case. I just can't stress this enough. It is not going to be that if you get through 500 LeetCode problems, you're going to be a successful programmer. It's just not true. It shows a propensity to be able to have the kind of drive to learn about what you need about programming, but you could get so narrowly focused on the gamification aspects of it and the instant reward aspects of it that if you went to move towards programming large, where you're having projects that last for months or years, that you may not get the motivation you need to be successful because you're so addicted to the fact that you can solve these problems within a day or an hour. Now, doing these small challenges can motivate you to learn a new language. That's great. To keep learning if you want to try to keep your skills up, if you're a more senior programmer, try to take a break from what you're doing in your day-to-day job. But again, it is not a proxy for general programming skills. And I'll talk more about this, but there's a real issue when people focus on this in job interviews. And this happens way more than it should. So I kind of like to talk about what I call the cult of no notation. There's a lot of programmers out there and a lot of people that do content that basically they know about O notation. They like to talk about O notation algorithms a lot. And I'm going to take a look at an LeetCode example, a fairly simple one, but it is on LeetCode there, which is basically if two strings are anagrams. And I'm going to present the simple solution here, which is basically, and this isn't Racket. So if you don't know about Racket, then you can look at my courses. Excuse me, I don't have any courses here. I'm not going to charge for that. I have some videos on the Racket programming language. There's also great programming resources out there as well from lots of other people. So, and it just the reason I use Racket is because it's fairly concise. You can show code up there in a pseudocode type of way that actually runs. So what I've done here is that I'm going to assume that you've blown up the strings into a list of characters. That's what A and B is. These are basically a list and stuff like that. So what I'm going to do is that I'm just going to sort the list of characters, and I'm going to sort this other list of characters. And if they're equal, you're done. They're an anagram. They have the same amount of letters. Right? They're in different position, but they have the same amount of letters. And that's all you need. That's all that matters. This is a perfectly workable and correct solution. That this is correct. And you can even reasonably kind of think about how to do that mathematically to say that this is correct. But in many cases, and what brought this up is I saw some content when I was doing some stuff on YouTube that this was unacceptable. Oh, this stupid junior person does this. Well, this takes n log n time to compute because we all know sorts take n log n. You know, the best sorts do, and at least it's not an n squared sort. But there it is. So a senior developer never hesitate to replace this. And a lot of you see about LeetCode, they talk about, you know, are you still a junior or you want to become a senior, or 10x versus 0.1x versus 1x? There's a lot of stuff that goes on in the online community that uses a lot of noise, but there's a lot of people that still kind of, you know, focus on this stuff. So basically, oh, well, this is NLN, therefore this can be done better in a linear time. I'm going to show you how to do it, and we're going to talk a little bit more about this. But first of all, here's the solutions with better algorithmic complexity may not be better overall in terms of when it comes to the overall code quality and given the domain they're actually in. And sometimes the senior solutions often have their own issues where they don't even realize. So the thing about it is understanding computational complexity is really useful. It's great that if you understand O notation that you know how to do these types of things. But it's often not applied effectively by a lot of people, and how you apply it is much different when you're talking about large-scale programs than basically the small little problems. So the thing about what happens is that also the other thing is that there's just common themes in LeetCode over and over again, where a lot of the problems just end up requiring you to have a certain facility in 3 or 4 type of concepts. Using hash tables is kind of a notorious example of this, as well as dynamic programming. You know, if you know how to do proper dynamic programming, you can do a lot of interesting problems. And using hash tables is an example of this. And the reason I bring this up is that, again, this content I saw, what the senior developer did is says like, well, clearly what you do to solve this problem is you create 2 hash tables, and you hash each character into the corresponding table, depending on what string it is, and then you compare to see if the 2 hashes are equal. And that, therefore, is the linear way of doing it. And that person was absolutely correct. And so let's take a look at what that looks like in kind of the Racket version of it. And again, there's more code here. This is much more verbose, but it's actually not too hard to get through. We're basically making 2 hash tables, one for all the characters in A and the other one for all the characters in B. I'm going to go through each of the characters in A. If it has this, if the character is in this hash table, I'm going to go ahead and set the value on that key to be 1. So I have to check to make sure that. So I'm tracking how many characters and how much time a certain character appears, because I need to do that. Otherwise, if it's not in there, then I need to insert it. So I'm going to go ahead and add the character into the hash table, and the value is going to be 0. I do the same thing for the B list, and then I go off and say, boom, is the A hash and B hash, are these tables equal? And thanks to Racket does structural equality, so it goes off and says, oh, yep, no, every element has to match every element here. It knows how to make 2 hash tables equal to each other, and so this works. And there you go. The solution is linear. You can do this. This is linear time. There's no sorts here. There's nothing to make it more complicated than linear. And a lot of people would stop there and say, well, done. This is clearly better. And, you know, woof. Great for me. Let's go on to the next one. And in general, this is true, but in general, but it's not the entire picture of what makes a good solution. And not only that, but there's sometimes where people do this And again, they get so used to doing things in a certain way where they just end up overusing certain types of concepts. Let's just take a look at a recursive solution I did. Straight old boring recursive version, right? So is an anagram A or B? First of all, are those two lengths are those two lists equal in length? Right? If they're not, you can't have an anagram. Strings that are not the same length can't be anagrams of each other. So that's the first thing I check for. All right. And not only that, but I do it to preserve the fact that this code will then work. If I have a list of only one thing in it, then that first element should equal the first element in this list, B. Not only that, but this B will only have one element in it because they are the same length, right? And then I just do the recursive case. Okay, now I'm going to assume that this works. So I'm going to set the first character of A to be this variable first in A, so I can reuse it in here. I'm going to ask the simple question: is this character in the other list? Right? This is what this member thing does. Right? If that is false, if it is not in the other list, then I do not have an anagram because I have a character that was in A that was not in B. Right? Can't be possibly the case. Otherwise, then it can be an anagram, but what I need to do is then check the following. Is the rest of the characters in that A list, which is the rest of them, the same as removing the first instance of this A character in the other list? And I had to go through and make sure in the scheme, in the Racket documentation, that this remove does exactly that, removes the first instance of this if it appears in B, which I've confirmed because this was true. This member text was true. This also does check to see if two things are anagrams. This is correct. This is also linear time. So in terms of computational complexity, these are the same. They're ON, end of discussion. So a lot of people in that regard, they're completely equivalent. But is that really the case here? And the answer is clearly no. And the one thing that the recursive version does that's really important, that the naive hash version, which that other person did do, was this. If you take a look at the amount of data that we're looking at, and in general, and I have to make some general assumptions here, the likelihood of two strings being an anagram is way smaller than them not being an anagram. So one of the things that you could do is that you want to then try to disprove that the two strings are an anagram. Be able to return false as soon as possible. And that's what my recursive version did. If the two things aren't even the same length, you're done. It's false, right? And then for every single character, it tries to make sure it can't be an anagram. It can't be an anagram. And as soon as it can't be, it returns false. And it's only until it's exhausted all the possibilities and every single character is as much matched up to another every single character in the first list has been matched up to another character in the other list, then it is proven to be true. The hash table does work that it may not need to. It hashes both those strings, puts all that information in there, and then checks to see if it's equal. It may not have to do that. Now, the hash table version can be fixed so that that isn't an issue, so that it doesn't do unnecessary work, and it'll be good and good exercise for you to do that. But it points out the fact that basically this senior person, who, by the way, also sells courses, on how to do this algorithmics and stuff like that, put this out there as a correct solution and the best solution in a way, when it's not, because it's doing worse time performance and not getting the average case. And the thing about it is the average case is going to be way better because you're way likely to prove that something is an anagram and do it relatively quickly when you're talking about strings in general. Given the context, though, of what we knew about the data, the sort solution might make sense. If this was a thing where it's like, well, we need to make sure that these two strings, which are no more than 64 characters, really aren't a permutation of each other, doing that sort of thing and checking if the two lists are equal, that's going to be fine. It's space compact. The logarithmic term is not going to dominate. And in this case, I would argue that basically it's possible that the overhead of maintaining the hash table in terms of memory and the time it takes to initialize that hash table will be the same or if not worse than the sort would be. Probably not, but it's not going to be that the sort solution is so obviously worse that it wouldn't make any sense to just like have to do it any other way. That could be good enough, just the sort way. And being able to talk about those trade-offs is important. And also that being explore things like, oh, are recursive versions are good or not versus the iterative versions. For example, if I'm a recursive guy, but I better go off and make sure that that recursive calls in tail call form, and I might do one or two things to really tweak that algorithm to make sure that is the case. So you don't argue that this is not going to just make recursive calls and run out of space if the strings are incredibly long. That's a good point. I have to be careful about that. One of the things about it is you could talk about how to do the iterative version of what I did, which is the recursive thing. There's this saying in programming that premature optimization is the root of all programming evil. Most people agree with it. There's a few people that don't. A lot of them kind of be very obsessed on basically, no, you should try to eke out as much obvious performance as you can. The thing about it is that for them, what's obvious is not necessarily as obvious to others, but in some cases, they're just people are very, very good at optimization. They really understand when things need to be better, and they have a good sense for it. But really, what it comes down to is that it doesn't rule out obvious optimization from the start. Doing things the obviously better way is fine when it's obvious and out there. But what it talks about is that people trying to optimize for something that they think is there, but really isn't a problem. And what it does is that it says, outside understanding of the real world that it's in, how it performs in the real world, given real world scenarios, you're not going to guess where the performance problems lie versus profiling the actual code to make sure that that's where the problems actually are. It's the hot spots. Running a profiler, where are the actual hot spots, how to optimize them, versus trying to optimize something that rarely gets hit, for example. And of course, languages vary on their support for profiling. Unfortunately, web programmers also get a hit in terms of profiling, and that it's not nearly as good as there are for things like C#, Java, C++, and all those other languages. They have great profilers out there, so you can really understand exactly how those things performs. And like in the case of C++, there's even great compilers out there that will do the things where they'll profile a code and how it's used in the real world over a long time, and they'll literally feed that back in to further optimize the code itself. And so we can automatically try to reduce some of those performance problems it saw from all that data that you fed it. So the other thing that's interesting here is that, these LeetCode things come up all the time in dysfunctional code interviews. And, I was thinking when I left my PhD program, I was working on finding jobs. These things came up a lot. I never really became an issue for me because I was able to get through them for the most part. And a few of the companies I interviewed, they were just mostly interested in seeing how I thought about things, and so they're using them the right way. But there was one noticeable interview that I did do in which they had kind of set up this problem, but didn't realize that it is ultimately a thing where if you knew how to do certain types of algebra on this, that basically you could reduce this thing into basically a quadratic formula. That basically, this was really just basically a roundabout way of computing something that was a quadratic. And so what I did is like, oh, okay, well then I'm going to show you how to reduce this quadratic equation. And so the solution to this problem is this, just basically you do this, square this, all that kind of stuff, and that will give you the number you want, right? And well, of course, that's very performant. You don't have to do any recursive calls, don't have to do any looping, don't have to do anything, right? You just do this thing, and you could just give it n. It's a function. You spits it out. You're done. The thing about it is that of course I didn't get that job because that person was probably had a fairly good say in who they wanted to work with, and it's fairly clear that they had no interest in working with somebody who basically got one over them on like that, right? They wanted to see someone struggle with that problem that they came up with, right? Versus just cutting through it and saying, well, clearly, obviously, it's just this, right? If you know what you're doing, and if you don't, that's fine, but I'll walk you through it. They had no truck with that whatsoever. And the thing about it is that I'm fine with that because I don't want to work with anybody who has that kind of attitude anyway, right? The thing about this, and this applies to all interviews, and it's really hard, especially for junior interviewers, but I'm here to tell you, the thing about it is that one of the best ways to get your foot in the door into a company and actually get a job is to have the confidence that if the job isn't a good match for you, that you're just going to walk away, right? It's really hard when you're looking for your first job, but I'm here to tell you that if you go in with this idea that, hey, not only do you need to know that I am a good match for you, but I need to know what this company is like to make sure it's a good match for me. That kind of confidence is really important. And if you have to fake it, then fake it until you actually get enough experience in your career to be able to walk away from those types of things. But I'm here to tell you, if you can't obviously be seen to be basically saying, you know what, I'm going to just take this job regardless of how awful I actually think it is or how terrible I think of a fit it is for me, you're not going to get that position. No one really wants to hire somebody like that, right? Versus somebody who says like, well, you know what, this is good enough for me. It may not be perfect, but I could see this giving a try, right? Even better, basically, it's like, you know what, you got to really prove yourselves to say, you know, have me become a team contributor because, you know, I'm really motivated. I really like this stuff, and I want to be in a place that allows me to do that and do that from day one. And is this that kind of place? Because if it's not, I will find the place to do it. So have that kind of confidence, even as a junior. So summary about LeetCodes here. It should be used for fun and keeping your brain working, not as a proxy for general programming experience or how successful a person will be in a team. And not only that, but basically, if you think you know everything about algorithmic and data structure and computational complexity, make sure that you actually do versus just having a surface level understanding of it. Because when you come up with somebody who actually does have a deeper understanding of it, you will look like an idiot. And it will be a pretty bad day for you in general. And so, again, it never goes well pretending you know more than you do, than basically being more skeptical about what you know, and then slowly moving forward and saying, okay, let me check this out. Let me check this out. Okay, then this is correct. I know how to do this. So, yeah, don't be that person. Anyway, if you like this video, I appreciate it, and I would appreciate it if you liked and subscribed and did all those wonderful things that lets YouTube know that we exist as human beings. Thanks, and I'll see you in the next video.